Moving 60 kilometers per hour is equivalent to dropping an elephant, or stegosaurus, from the top of a 3-story building. And in order for the car to stop, all that energy has to go somewhere. If the brakes do the stopping, they dissipate the energy by heating up. Or in the case of a collision, energy is dissipated by the bending and crumpling of metal in the outer areas of the car. And just like how smooth braking is nicer than a quick, jerky stop, cars are carefully designed to crumple when they crash, in a way that lengthens the duration of the impact so that stopping requires less intense acceleration. Lots of acceleration over a very short time is not good for soft human brains and organs. However, people don't like driving cars with Pinocchio-length noses, so most cars only have around 50 centimeters of crushable space in which to dissipate the energy equivalent of our falling stegosaur. That means that while crumpling, they need to maintain a resistive force of about a quarter of the thrust of the Space Shuttle main engine. Over half of the controlled crumpling work is done by a pair of steel rails connecting the front bumper to the body, which bend and deform to absorb energy and slow the car. Most, and in ideal circumstances all, of the rest of the energy is absorbed by the deformation of other pieces of structural metal throughout the front of the car.
Stopping distances are composed of two parts.
Hello!
The thinking distance and the braking distance. Here you can see 3 cars of different velocities. The red car is the slowest and blue the fastest. Here is the red car's thinking and braking distance. Here is the white car's, and here is the blue car's. As you can see, with the greater initial speed, the total stopping distance is increased. The blue car here took the longest distance to stop as it was going the fastest. The thinking distance is shown here in purple, and the braking distance in green. Here is a graph, with speed on the x-axis and distance on the y-axis. Using purple for thinking distance and green for braking distance again, you can see how speed affects each of them. There are things that can affect both of these other than speed, however. Drinking alcohol can increase your thinking time. Taking drugs can increase your thinking time. And being tired can increase your thinking time. There are 2 factors that affect braking distance. More friction decreases it. More momentum increases stopping distance. A wet road will reduce friction and increase stopping distance. This heavy FedEx truck, which is heavier than this small blue car, will have more momentum when going at the same speed and so take longer to stop.